Okay, so the point of this video is to talk about where all the Pythagorean identities come from. The first one we've already talked about in class, but let's prove it again just one more time anyway. You can do this in terms of the unit circle. I think is probably the easiest way of proving it. And remember, theta is any angle in standard position. So, like, let's say this is theta here. And since it's the unit circle, it's radius 1. It's got the equation x squared plus y squared equals 1 squared, so that's just 1. And this point here is x comma y. And remember, we figured out that x is the same thing as cos theta. Y is the same thing as sine theta. And if all I do is a substitution into the equation of the circle, or you could alternatively figure out that this length right here is the same as cos theta and this right here is the same as sine theta, and then you could do Pythag. But in this case, just plug it into here, you'll get cos squared theta plus sine squared theta has to be 1, which is the same thing as this first one right here, just flipped around. The second one we can get by applying rules of, tan is x over or y over x and secant is, and do all that kind of stuff. But I think it's easier to base everything off of this first one. So if I actually just rewrite this first one here, sine theta plus cos squared theta, sine squared plus cos squared equals 1. I can get tangent out of this by dividing this one by cos squared. But if I do it to that term, I got to do it to all the terms. And if I do it to all the terms, then the nice thing is that this turns into tan squared, this turns into 1, and this turns into secant squared. So now I have the second one. In order to get the third one, well, we could do two things. One is I could take the second one and divide everything by tan squared, but I'm not very good at looking at secant squared over tan squared. So instead, I prefer to take the first one, and in order to get 1 here, I'm going to divide by sine squared. And so I got to divide everything by sine squared. And if I do that, then I end up with 1 plus, and this is cotan squared theta, and 1 over sine is cosecant, but it's 1 over sine squared, so it's cosecant squared, and now I've got my third one. One thing to note, sometimes it's useful to look at these slightly differently. For example, a lot of times you'll end up with a problem where you get something like 1 minus cos squared over like sine theta, let's say. So that would be an example. If you end up with something like that, this can be simplified pretty quickly, but you have to be able to look at that and say, oh, that's the same thing as sine squared theta. And so I've got it divided there, and then this just turns into sine theta. Another trick is that some people don't really think of 1 minus cos squared as sine squared, but what you could do also is replace the 1 with sine squared plus cos squared, and then what will happen is this cos squared will cancel with this negative 1, and you're just left with the sine squared on top. So you could do it that way too, but I think it's probably better in the long run if you start looking at this one in particular 3 different ways. Sine squared plus cosine squared equals 1, cosine squared equals 1 minus sine squared, or sine squared equals 1 minus cos squared. Those are the 3 ways you probably want to think about that very first one.